Whether it's smooth sailing or rough riding in the open seas, a gentle breeze, or the mighty rumbling of thunder, constant rain showers, or the scorching heat of the desert. There's no escaping nature. Let's explore and learn about nature's awe-inspiring feats. Marvel at the amazing sights and sounds. This is nature's force. Dust storm. You must take cover quickly when a dust storm happens. Now, as the dust settles, let us discuss the facts behind the phenomenon known as dust storms. A dust storm is a meteorological phenomenon caused by strong winds that carry loose sand particles. This type of phenomenon happens in arid or semi-arid regions where there are vast amounts of loose sand. In these desert regions, dust storms occur regularly. It is estimated that as much as 80 dust storms occur every year. A sandstorm can carry a lot of dust, estimated to be about 1.6 kilometers thick. Sandstorms are caused by strong winds blowing over loose soil and dust particles. Strong winds are the result of storms and other changes in atmospheric pressure. Meanwhile, the loosening of soil and dust particles are the result of many related conditions. Wind blowing over solid masses of rock and soil tend to degrade and loosen small particles over time. A lack of precipitation or drought also causes dried up soil and sand to become loose. Activities like farming and other processes that involve digging through soils also contribute to its loosening. When strong winds blow over these loosened particles, you get a dust storm. Let's take a look at the effects and hazards that dust storms cause. In instances of very strong wind, dust storms are known to take down trees. The dust that it leaves behind usually covers equipment and other items that are left outside during storms. This includes vehicles, machinery, lawn equipment, signage, streetlights, tents, and other items typically found outside houses and buildings. These can cause structural as well as internal damage. Buildings and houses are also prone to damage as the wind coupled with particles accelerate wear and tear by way of friction and abrasion. Unsecured and poorly built structures are also prone to being carried away in more extreme conditions. Visibility takes a dive during dust storms. That's why land and air transportation is usually disrupted. Exposure to dust storms are also detrimental to certain species of animals. Dust can affect their breathing, which can lead to animal casualties. Physical injuries caused by dust storms are also common. Sandstorms also affect plant life and vegetation. It can destroy crops and strip the soil of nutrients, thus stifling agricultural activity and food production. While winds cannot be stopped, there is still something that can be done to lessen the formation of loosened soil. Among them are agricultural solutions like planting trees and grass, and shifting to sustainable farming practices. People living in dust-storm-prone areas prepare by covering cars and outdoor equipment with a secure and dust-proof fabric. Goggles and gas masks are also advised to be worn to protect one's face and prevent dust storm-related conditions. Clouds. If you look up in the sky, you'll see them. A floating mass that sort of resembles cotton-like structures of different shapes and sizes. Clouds. So for now, let's take a closer look. So, what are clouds? Well, previously, we have been introduced to clouds as condensed water vapor floating in the Earth's atmosphere. More specifically, a cloud is a visible aerosol that consists of a mixture of liquid droplets, frozen crystals, and some other particles suspended in the atmosphere. Cloud formation is also a part of the natural water cycle. When evaporation occurs, water from oceans, lakes, rivers, and other places on the surface of the Earth turn into water vapor and travel through the atmosphere. As the water vapor travels higher into the air, it gets cooler and eventually condenses into small water droplets and sometimes even ice crystals. Water vapor will also combine with other particles in the air, such as dust, smoke, and pollen, to form what is called a condensation nuclei as it condenses. The small water droplets and ice crystals is what gives the cloud its visible appearance. Oftentimes, clouds appear white, but sometimes they can also look grayish. This is because water droplets and ice can scatter and reflect light. Clouds reflect sun rays, which makes them appear white. But as clouds increase in mass and become thicker, there is less light to reflect. This makes clouds appear darker, and is also an indicator that it is about to rain. Clouds are usually classified based on the altitude or height where they are formed. Clouds formed above 20,000 feet are usually termed with the prefix cirro or cirrus. These types of clouds are mostly made up of tiny ice crystals and have a feathery appearance. Clouds formed between 6,500 to 20,000 feet have the prefix alto. These clouds are made up of a combination of water droplets and ice. Clouds formed at 6,500 and below are called stratus, and they are mostly composed of just water droplets. There are also vertically formed clouds that are formed in between the different levels of the atmosphere. These are called cumulus. Clouds are usually described by combining the naming terms that describe them. For example, cirrus clouds are thin and wispy. These usually indicate good weather. Altostratus clouds are dark and gray clouds, an indicator of rainy weather. Nimbostratus clouds, on the other hand, are thick and gray. They usually indicate either rainy or snowy weather. In addition to that, clouds also serve another useful purpose. Clouds provide some shade from the heat and light of the sun, and thus directly affect the temperature of the Earth's surface. Being part of the water cycle, clouds are part of the planet's greater weather system. And observing clouds provides useful data and insights into reading and predicting the weather. Lightning. This often accompanies stormy weather. Nature's awesome display of light and energy. It can only be lightning. Lightning is what is called an electrostatic discharge. This occurs when the electrically charged regions in the atmosphere and the ground equalize and release a sudden burst of energy. This energy is so strong that it can contain as much as 5 gigajoules of energy, which is approximately equivalent to the energy of 38 gallons of gasoline. Lightning needs very specific conditions for it to occur. Electric charges in the atmosphere are caused by the ionization of air molecules due to being exposed to cosmic rays from outside the Earth. When these collide with air molecules, they get charged. As more water vapor in the clouds freezes, the small bits of ice bump into each other and cause the cloud to build up an electrical charge. Positively charged particles gather at the top of the cloud, and the heavier negatively charged particles move to the bottom. When the charge grows large enough, the energy can no longer be contained and must be released. It will travel in the direction with an opposite charge as lightning. Of course, we can't talk about lightning without discussing the accompanying sound it makes, or what's more commonly known as thunder. Lightning carries enough energy that can create heat at temperatures of about 25,000 degrees Celsius. This causes surrounding air to rapidly heat and expand at a rate that is faster than the speed of sound. This effectively creates a sonic boom effect, and this is what makes the loud, boomy rumbling noise of thunder. There are mainly 3 kinds of lightning, as categorized by where they are formed. First, lightning can occur within a single thundercloud or intracloud. Second, lightning can also occur between 2 different clouds, or cloud to cloud. And lastly, lightning also occurs between a cloud and the ground below, or ground to cloud. Lightning has several devastating effects because of the immense amount of energy that it contains. Trees and plants hit by lightning may catch fire. Animals and humans alike may suffer from injuries to their organs and nervous systems after being struck by lightning. Lucky for us, however, statistics say that 90% of people struck by lightning have survived. Tall structures and buildings are more likely to get struck by lightning, although there are generally no dangerous effects. Man-made structures called lightning rods or lightning arresters have been constructed to be specifically hit by lightning. This helps prevent unwanted accidents and are also sometimes used as tools to study lightning phenomenon. Lightning also plays a role in the nitrogen cycle. By oxidizing nitrogen and releasing nitrates into the air. This contributes to the growth of plants and organisms. Rain. Water falling from the sky. Let's talk about rain. Rain is the most common type of precipitation, or simply water that is released from clouds. Due to the Earth's unique atmosphere, the air around us is full of water, even though we cannot see it. When discussing rain, it is also important to discuss the water cycle, or the natural processes that our planet's water goes through. Let's take a look. First is the process of evaporation. When water is heated, it undergoes a change from a liquid state to a gas state. The heat that triggers this process comes from the sun. This process can be observed in many ways, like the drying up of puddles in the street, or air drying laundry during a sunny day, and so on. When water evaporates, it becomes lighter. But as it reaches the atmosphere, it undergoes another process called condensation. Here, the water vapor condenses into small water droplets, which form clouds in the sky. The water vapor in the clouds are very small, and thus are able to float freely in the air as clouds. But when more and more water vapor forms in the clouds, they become bigger and heavier. The bigger and heavier water droplets combine with other particles in the air, such as dust, salt, or smoke, and form even bigger droplets. These bigger droplets undergo more condensation, and when the droplets are big and heavy enough, the result is water falling back to the ground, or simply rain. Now, in some cases, precipitation may also appear in different forms, aside from rain, given the right conditions. At freezing temperatures, water droplets in the air may freeze before falling to the ground. This is more commonly known as snow. Sometimes, water droplets may freeze and be sucked up again in the atmosphere, causing layers of water to build up and freeze over time. This eventually forms a bigger ice pellet, or what is more commonly known as hail. Rain can also be supercooled, which means that the water droplets retain its liquid form, but freeze upon hitting the ground. Now, let us take a look at the shape of raindrops. Water droplets that have a radius of 1 millimeter usually appear round. But as droplets grow in size, their bottoms usually get flatter. At 3 millimeters, there will be a visible indentation at the middle of the droplet. And finally, at around 4 to 5 millimeters, the indentation breaks the water droplet in the middle, forming a parachute shape which results to smaller droplets. Rainfall over different regions of the Earth are different. This has something to do with the position of certain areas on the Earth. Deserts usually experience less rainfall because they are located in places that receive more sunlight and are therefore warmer and drier. On the other hand, regions in the tropics receive more rainfall than other places. While rain is mostly just water dropping back to the earth, given the conditions like wind and the temperature, rainfall can be part of storms where massive amounts of rain can cause flooding and other hazards associated with it. El Niño. This phenomenon might sound a bit peculiar to some and may be more familiar to others. Let's talk about El Niño. To our Spanish-speaking audiences, El Niño literally translates to the boy. But for meteorologists and people whose livelihoods depend on the weather, it is a whole nother thing. El Niño is part of the warm phase of what is known as the El Niño Southern Oscillation, or ENSO. The ENSO is a cycle of warm and cold temperature on the surface of the sea. This usually occurs in the tropical central and eastern regions of the Pacific Ocean. El Niño is characterized by the presence of warm ocean water in the central and eastern central Pacific. It is usually accompanied by high air pressure in the west and low air pressure in the east, affecting areas and regions close by. The term El Niño actually comes from the El Niño de Navidad, based on the Spanish term for newborn Christ, a reference to Christmas. This is because fisherfolk from South America usually observe the warming of waters during the Christmas season. But accounts and actual occurrences of El Niño may vary. And actual El Niño events have been observed to occur from 2 years to as long as 7 years. Because of the changing of the sea's temperatures, El Niño drastically affects normal weather patterns. This causes strong and intense storms in areas of low pressure, while in other places, little to no rain at all, even causing drought in some areas. Let's take a look at how El Niño's effects vary from different regions on the planet. Places near the equator like Indonesia and the northern parts of South America receive below average rainfall, while regions in South America near the eastern Pacific Ocean receive increased rainfall and thunderstorms. On the other hand, countries in Africa experience wetter than normal conditions from March to May, and drier than normal weather during December to February. In the Asia-Pacific region, El Niño usually causes extensive drought. Reduced rainfall is also observed in Australia. And because of the way El Niño affects the weather, it also has varying effects on humans. Countries with economic industries built on fishing and agriculture might be severely affected because of droughts and storms. Fish also behave differently, sometimes changing migration patterns to avoid the warm regions of the ocean. Coral beds and sea habitats are also damaged by the rising temperature. This contributes to less supply for commercial fishing. Extended periods of drought also affect the ecosystem as plants and trees receive less rainfall. Another consequence of drought is the increased risk of forest fires. And finally, the changing of the weather also affects human health. The risk of tropical diseases transmitted by mosquitoes, such as dengue and malaria, are often related to shifts in the weather. And given the right conditions, El Niño may directly contribute to its increased transmission. We are nearing the end of this episode. But before we go, let's take a quick recap. In this episode, we talked about dust storms, the weather phenomenon caused by strong winds carrying loose sand particles, and the arid desert regions where these usually occur. While dust storms cannot be stopped, better ecological and agricultural practices may help lessen its harmful effects. We also learned about clouds, a visible aerosol that consists of a mixture of liquid droplets, frozen crystals, and some other particles suspended in the atmosphere. Clouds also have different sizes and shapes. Cloud formation is also part of the water cycle and the Earth's weather system. We also discussed about lightning, an electrostatic discharge that occurs when the electrically charged regions in the atmosphere and the ground equalize and release a sudden burst of energy. We also discussed how this naturally occurring phenomenon is accompanied by a loud rumbling noise called thunder. We discussed how rain is formed from the water vapors in the atmosphere as part of the planet's water cycle. From evaporation to condensation, and finally precipitation. Different parts of the Earth receive different amounts of rainfall. This has something to do with the different regions of the Earth having different climates and geological features. And finally, El Niño is a weather phenomenon that is part of the ENSO. It is characterized by the changing of surface temperatures of the ocean in Central and Eastern Central Pacific. This change of temperature causes a shift to usual weather patterns, often causing excessive rain and prolonged droughts, depending on the geographic location of affected regions. Heatwave. While summer is usually a period for vacations and holidays, it's not always fun under the sun. Sometimes, the weather gets too hot to a point where it becomes harmful to humans and the environment. So today, let's talk about heat waves. A heat wave is defined as a period that is characterized with excessively hot weather. It is sometimes accompanied by high humidity in oceanic regions. Heat waves are usually identified relative to normal temperatures for a specific area. That is why temperature classifications may vary from country to country. Oftentimes, temperatures that may be considered a heat wave in a cooler region may be normal for regions near the tropics. Heat waves occur when a high-pressure area forms over a landmass and traps the heat from the ground, resulting in a prolonged increase in temperature. So now, let's take a look at the different ways that scientists in different regions define what a heat wave is. The World Meteorological Organization defines heat waves as 5 or more consecutive days of prolonged heat, where the maximum temperature is 5 degrees Celsius higher than the average. In the US, definitions vary from different regions. But typically, they share the same definition of at least 2 or more days of excessively hot weather, where the temperatures exceeds 90 degrees Fahrenheit. In Australia, a heat wave is defined as at least 5 consecutive days where the temperature is 35 degrees Celsius or 95 degrees Fahrenheit, or 3 consecutive days where the temperature is over 40 degrees Celsius or 104 degrees Fahrenheit. On the other hand, the UK uses a level system for its Health Heat Watch, which is based on the differences between daytime and nighttime temperatures and the thresholds established in specific regions. The levels indicate the type of response from concerned government agencies. Level 1 is normal. Level 2 is when there is a 60% risk for the temperature to increase above threshold for 2 days and 1 night. Level 3 is where there is 90% chance for the temperature to stay above threshold for the next day. And Level 4 is triggered when there is a need for a widespread response from the authorities. Heat waves also affect energy consumption, as the demand for electricity to power air conditioning devices rises during periods of hot weather. In 2006, parts of North America were left without electricity when electrical transformers failed during a heat wave. The excessive heat also causes physical damage to roads and railways. Asphalt from old roads can melt due to the increase in temperature. This also can cause old railways to kink and buckle. There is also an increased risk of wildfires during this time. Great care must be exercised when faced with a heat wave. The risk for heat-related illnesses greatly increases during this period as well. These include heat rashes, heat cramps, dehydration, exhaustion, heat stroke, and the like. If you are experiencing a heat wave in your area, it is advised to stay indoors and keep hydrated to mitigate its effects. Fujiwhara Effect. It might sound like a name for a kaiju movie, but it is in fact another meteorological phenomenon. So for now, let's take a look at the Fujiwhara Effect. The Fujiwhara Effect, which is also known as the Fujiwhara Effect without an H, is the weather phenomenon associated with the formation and movement of two nearby cyclones, as they move around each other and close the distance between their low-pressure areas. In some instances, the interaction between the two smaller cyclones causes them to merge into one bigger cyclone. The name of the effect can be traced back to Japanese meteorologist Sakuhei Fujiwara, who was the first to study and observe the effect in 1921. Now, let's take a closer look. When cyclones are in close proximity to one another, their centers will start to move in circles around each other cyclonically, or counterclockwise for regions in the northern hemisphere, and clockwise for regions in the southern hemisphere. The forces between the two vortices will attract each other and move in a spiral fashion to a center point and eventually merge together. Sometimes, when the vortices of the cyclones are of unequal size, it is observed that the smaller vortex tends to circle around the bigger vortex, and eventually, the bigger vortex will absorb the smaller one. In 2009, Super Typhoon Malor interacted with Typhoon Parma in the Philippine Sea, causing Typhoon Parma to change directions after landfall. In 2017, Hurricane Hilary and Hurricane Irwin merged in the Eastern Pacific Ocean. In April of 2021, Tropical Storm Siroha and the weaker Cyclone Odette circled each other at the western Australian coast, with Siroha eventually absorbing Cyclone Odette. The Fujiwhara effect can be observed in tropical cyclones as the vortices of the smaller low-pressure areas approach within 1,400 kilometers or 870 miles of each other. As both pairs move closer to a distance of 650 kilometers or 400 miles, their rotation begins to accelerate. And finally, when they are really close to each other at a distance of 300 kilometers or 190 miles, they begin to merge. The effect can also be seen with extratropical cyclones with distances of about 2,000 kilometers or 1,200 miles from each other. The vortices start accelerating when they are at a distance of 1,100 kilometers or 680 miles from each other. Interactions observed at 500 hectopascals at 18,000 feet above sea level are usually considered to be more predictable. At this level, extratropical cyclones can either merge as one cyclone or, in rare cases, might result to the change in direction for both cyclones. But all of these would depend on many factors, such as the size of the cyclones, their distance from one another, and other atmospheric conditions. Flood. Don't get your shoes too wet, because when it rains, it pours. And you know what comes next? For now, let's talk about floods. Floods are defined as the overflow of water over land that is usually dry, causing it to submerge. Now, floods can be caused by a number of different factors. So, let's take a look. Floods are commonly caused by excessive amounts of precipitation, usually in the form of rain. But in some cases, snow that has melted might also be a cause for flooding. Another cause of flooding is the rising of the tide due to lunar movement. Floods can also occur when levees of small bodies of water break or overflow. While often naturally occurring, sometimes human activity such as construction, farming, deforestation, and other industrial activities may also directly or indirectly cause flooding. Now that we have checked out what causes flooding, let's take a look at its different types. Aerial floods are floods that occur in low-lying areas when there is excessive rainfall or melted snow. Riverine floods are floods that occur near rivers and stream channels. This type of flood happens due to various factors like rain, snow, and even landslides. Often, this type of flood carries mud and sediments. Estuarine and coastal floods are floods near coastal areas. This is usually caused by storms and sometimes a combination of storms and tides. Urban flooding is the type of flood that occurs in human-built urban environments like roads and cities. And finally, catastrophic flooding is the type of flood that is related to major infrastructure failures, such as a collapse of a dam. It can also be triggered by other catastrophic events, such as landslides, earthquakes, or volcanic eruption. While floods usually dry out after a period of time, prolonged flooding poses some serious effects, including damage to infrastructure, buildings, roads, and sewage systems. Flooding may also affect the supply of power and electricity during extreme circumstances. The risk of contracting waterborne diseases such as typhoid, cholera, and giardia also increase during times of flood, as well as the risk for drowning. This directly affects human life and survivability. So, what can be done? Luckily, there are some things that we can do to mitigate flooding and its effects. These include engineering solutions like constructing detention basins, artificial levees, and reservoirs. In combination with these, there are also mechanical solutions that involve pumps, rain barrels, and flood valves. Low-cost temporary solutions like sandbags can be used as makeshift barriers. Beach nourishment, or adding of sand to the shoreline, is also used to mitigate coastal flooding. And long-term, eco-friendly solutions include planting trees to help prevent flooding and soil erosion during times of heavy rain. Blizzard. Get your winter coats ready. Or better yet, stay indoors, because this next one is about to get chilly. We're of course talking about blizzards. A blizzard is a strong type of snowstorm, where there is snowfall and strong winds with minimum speeds of 56 kilometers per hour or 35 miles per hour, and is sustained for a prolonged period of time of at least 3 hours or more. According to the Oxford English Dictionary, the term blizzard is most likely onomatopoeic, or words that are used to convey sounds like boom or swish. The word blizzard is derived from other words like blow, blast, blister, and bluster. Though it originally meant a violent blow, the term achieved its modern definition during 1859 and became commonly used to describe the 1880 harsh winter conditions in the western United States. Blizzards form when jet stream air currents move cold, dry air from the poles and clash with the warm, humid air moving up from the south. The polar air creates the conditions to make the weather cold enough for snow, while its interaction with the warm, moist air creates strong winds due to low-pressure areas. While we are looking at its definition, let's take a look at how different regions in the Earth classify blizzards. The United States National Weather Services differentiates blizzards from snowstorms based on the speed of the wind. Blizzards must have sustained winds of 56 kilometers per hour or 35 miles per hour or more. A severe blizzard, on the other hand, happens when the wind speed is above 72 kilometers per hour or 45 miles per hour. At these conditions, there's zero visibility, and the temperatures drop to negative 12 degrees Celsius or 10 degrees Fahrenheit or even lower. In Antarctica, blizzards can have average wind speeds of 160 kilometers per hour or 99 miles per hour. Now, let's take a look at some of the strongest blizzards recorded in human history. In 1972, Iran experienced what some call as the deadliest blizzard in history. Low temperatures and severe blizzards lasted from February 3 to 9. Almost 3 meters or 9.8 feet of snow accumulated in the northwestern, central, and southern regions of the country. This resulted to a death toll of over 4,000. In March 1993, a large cyclone storm formed over the Gulf of Mexico. This came to be known as the storm of the century. The storm was so massive that it stretched from Canada to Honduras, but its main impact affected parts of the United States and Cuba. Areas such as Alabama and Georgia recorded up to 12 inches or 30 centimeters of snow. Louisiana, Cuba, and Florida experienced storm surges and scattered tornadoes. As much as 10 million people in the United States were left without electricity. While costs of damage to property were estimated to be around 6 to 10 billion US dollars, with an estimated 310 fatalities. Measuring rainfall. So we have, in the past episode, discussed the weather and the rain. But now, it is time to take a deeper look. Let us discuss how rain is measured and why this is important for meteorologists, researchers, farmers, and government agencies. Measuring rain has many applications. For farmers and those in the agricultural industry, keeping track of rainfall is important to aid them with the irrigation demands of crops, especially during planting season. Measuring rainfall also goes hand in hand with water collection. While the earth is composed of 2/3 water, most of it is salt water in the seas and oceans. A huge part of fresh water actually comes from rainfall, and because of this, rainfall measuring and collection is helpful, especially in areas where access to fresh water is scarce. Another application would be for data collection to help in weather forecasting. And finally, government agencies can use rainfall data to prevent or mitigate disasters. They can also use rainfall data for engineering projects such as dams, sewage systems, and flood control projects. So, how is rain measured? Let's look at the different ways. Typically, rain is measured in units of length over time. For example, millimeters per hour for metric system countries, or inches per hour for imperial system countries. One of the simplest tools used to measure rain is called a rain gauge, which is a calibrated container placed outside to collect rain. A more modern approach is with the use of a radar. Radars work by sending and bouncing wave pulses to estimate the amount of rain in a given area. They do this in conjunction with rainfall estimates from research data. Now, let us take a look at how rainfall intensity is classified. This is primarily based on the rate of precipitation over a period of time. Light rainfall is when the rate of precipitation is less than 2.5 millimeters or 0.098 inches per hour. When precipitation is between 2.5 millimeters or 0.098 inches to 7.6 millimeters or 0.30 inches per hour or 10 millimeters or 0.39 inches per hour, this is classified as moderate rainfall. Heavy rainfall is when the precipitation rate is less than 7.6 millimeters or 0.3 inches per hour, or between 10 millimeters or 0.39 inches per hour and 15 millimeters or 2 inches per hour. And finally, the strongest intensity when precipitation is greater than 50 millimeters or 2 inches per hour. This is classified as violent rain. Another measurement of interest to rainfall is the return period or the probability of an event with a specific intensity or duration to occur again. You might hear it in the news, where weather reporters say something like 50% chance occurring over a 10-year period or something similar. The term 1 in 10-year storm describes unusual rainfall events that have a 50% chance of happening over a 10-year period, while the term 1 in 100-year storm is a rainfall event with a 50% chance of happening over a 100-year period. as probabilities go. However, it is still possible, although highly improbable, to have multiples of these events happening in the same year. We are nearing the end of this episode. But before we go, let's take a quick recap. In this episode, we learned that heat waves are extended periods of excessively hot weather. They are defined based on average temperature classifications of different regions. Heat waves are formed when a high-pressure area over a landmass develops and traps the heat from the ground, resulting to increased temperatures over a period of time. The Fujiwhara Effect, named after a Japanese meteorologist, is a weather phenomenon where two cyclones that are close together move in together, and usually the stronger of the two tends to absorb and merge with the other. Floods are defined as an overflow of water that submerges an area of dry land. These are caused by many factors. Among them are precipitation, like rainfall and melted snow, the breaking of levees of bodies of water, and tidal movement in coastal areas. Human activities such as agriculture, industrial construction, and deforestation also indirectly contribute to flooding. Blizzards are a type of extreme snowstorm with strong wind speeds starting at 56 kilometers per hour or 35 miles per hour, which are sustained for 3 hours or more. These are formed when cool polar air mixes with warm humid air, forming the conditions for snow and strong winds. And finally, we took a closer look at the importance and the methodology involved in measuring rainfall. With its numerous applications in meteorology, agriculture, economy, freshwater collection, and disaster relief. Rainfall intensity is classified according to the rate of precipitation per hour. Seasons. You may not realize it, but these definitely affect us more than we might care to admit. Our clothes, our weather, the environment, and even our activities. Have you guessed it? We are talking about, of course, winter, spring, summer, and autumn, or simply the 4 seasons. Now, the way we experience seasons varies depending where you are located on Earth. Places near the equator experience somewhat similar weather, with slight variations all year round. While for regions in the northern and southern hemisphere, seasonal changes are more definitive. Like, say, the difference between summer and winter, or spring and fall. But why do seasons happen? Well, this has something to do with how our planet is tilted towards the sun. Because of this tilt, parts of the Earth's surface lean closer to the sun, depending on the time of the year. Areas that are tilted towards the sun are more exposed to the light and heat, and therefore become warmer, or what we commonly know as summer. While the areas tilted away from the sun become cooler and experience lower temperatures, or what we commonly call winter. While other areas which are parallel to the sun experience autumn and spring. But wait, didn't we mention that places near the equator experience seasons differently? That is because their unique position on the Earth means that they pretty much receive consistent heat and exposure to the sun. There is also another factor that affects the seasons in the regions of the Earth. This has something to do with the Earth's orbit. Having an elliptical path means that there are certain times of the year where the Earth is farther from the Sun, which means less heat and lower temperatures. Now, let's take a look at seasons. Spring is typically associated with warm and wet weather. This is the usual time for harvest. For some animals, this signals their time to awaken from hibernation. Summer is when things get hot. Summer is the season associated with the highest temperatures of the year, the period where a particular region is closest to the sun. This is also the period where spikes in temperatures may happen, which can cause heat waves. On the other hand, autumn is the season where temperatures start to cool down. For some animals, this is the period to gather food and prepare to hibernate for winter. For migratory animals, this is the time for them to move to warmer regions. And one of the most noticeable features of autumn is when plants shed leaves and become dormant. That is why autumn is also called fall. And finally, we have winter, the coldest season of the year. This is when temperatures drop and cause precipitation in the air to freeze, or more commonly known as snow. For hibernating animals, this is the time to undergo a resting state. While humans need to adapt to the cold with the help of warmer clothing and by staying indoors lest we freeze. Drought. Hold on to your farming hats, because this one is about to get hot. So hot in fact that we might just need water. Well, that's what we are going to talk about today. Let's talk about droughts. In the past episodes, we have been learning about precipitation and rain. But what if it doesn't rain? Well, that's exactly what droughts are. A period characterized by below normal precipitation in a given region that causes shortage in the supply of water. Without any rain or precipitation, soil may have reduced moisture. Groundwater reservoirs may become depleted, crops might get damaged, and there might be water shortages. Can you imagine that? Now, there are many factors that can contribute to drought, so let's take a look at them. One of the main reasons for drought is low precipitation. This meteorological phenomenon is caused by high amounts of reflected sunlight and the prevalence of high-pressure winds that usually prevent the formation of storms and rainfall. Another cause of drought is the natural occurring dry season due to the movement of the Intertropical Convergence Zone, or monsoon trough. During the dry season, more water vapor is required to reach humidity values to 100%, which in turn triggers precipitation or rainfall. Another cause for drought is the El Niño, the meteorological phenomenon associated with warm, dry air spreading in the central regions of the Earth. While these are naturally occurring, human activities involving farming and agriculture, deforestation, and erosion may also contribute to droughts. Farming usually involves massive amounts of irrigation, while industrial activities, which cause soil erosion, may impact the natural ability of land to hold water. Now, as we all know, water is essential to life, and so droughts in themselves have very significant implications to humans and the environment. Droughts can affect water supply, which means it not only affects humans, but animals and plants as well. Excessive periods of drought can be detrimental to biodiversity of the environment. Forest fires are another consequence of drought, and without enough water supply, these may worsen too. When talking about droughts, there's also a high impact on the economy, especially in industries that are dependent on water. These include agriculture, farming, fishing, food supply and production, hydropower, mining, paper, and many more. And last but not the least, the social and health implications of drought for humans, including heat-related sickness, malnutrition due to food and water shortage, increased levels of pollution, and the list goes on. But while some forms of drought cannot be completely avoided, there are fortunately some steps that we can take to mitigate its effects. These include measures like dam construction, cloud seeding, and utilizing seawater through the process of desalination. Land use planning is a series of measures that include crop rotation and the utilization of crops that require less water. Other measures include water conservation, like restricting water at home, regulating sprinklers, pools, and etc. Other steps include harvesting rainwater and recycling wastewater to be clean enough to be used again. And finally, data on droughts and the weather can also be used to monitor and predict when large-scale drought may occur, and thus allow us to prepare if the need arises. Hurricane. For this next one, you better stay indoors because this might blow you away. Let's talk about hurricanes. Hurricanes are tropical cyclones or storms that are usually characterized by a low-pressure area. It moves in a circular motion and often comes with strong winds and sometimes with rains and thunderstorms. The term hurricane is used to define tropical cyclones that occur in the Atlantic Ocean and the northeastern Pacific Ocean. They typically move in a cyclonic fashion or in a counterclockwise rotation. These two are what differentiates hurricanes from another type of tropical cyclone, the typhoon. But other than that, the same natural processes that are involved in the formation of a hurricane are the same. And with that, let's move on and take a look at how hurricanes form. Hurricanes develop during the summer, when the ocean air is warmer. The warm and cool air undergoes convection, where they move together and form an area of low pressure, causing the movement of winds. When the surface winds converge towards each other, they start to circulate and their speed increases. As they move faster, they form an identifiable center, and this is now classified as a tropical depression. When the speed of the wind reaches speeds above 63 kilometers per hour or 39 miles per hour, the tropical depression is now considered a hurricane. Hurricane speeds do vary, as well as the force that they exert. Hurricanes carry strong winds, and this is usually accompanied by strong rains and, of course, flooding. In some instances, this strong wind and flooding can cause detrimental effects to humans and the environment, including the disruption of shipping and fishing activities due to the strong winds and the waves that it causes, making seafaring and related industries very unsafe. Hurricanes are also known to damage and sink ships, causing shipwrecks. And you need not look far for proof. Many shipwreck stories from history will attest to that. Now, land-loving dwellers are not safe either, and will experience their share of the hurricane's force. strong enough hurricanes can cause terrible damage to property, destroying houses, buildings, infrastructure, and vehicles along its path. People and animals, including pets and livestock, are also very much at risk during these times. Power outages are common as well. And speaking of health, flooding brings with it waterborne illnesses, which become prevalent during hurricane season. And so, what can be done to mitigate these effects? Well, while hurricanes cannot be completely avoided, there are systems that help us forecast their occurrence and movement, albeit only a few days before they reach populated areas. These include satellite imaging for storm forecasting, as well as years of data from previous hurricanes. The good news is, we can prepare for such events. Aside from forecasting, governments and authorities have put in place risk assessment measures, especially for hurricane-prone areas. These include preparing adequate supplies of food, medicine, emergency power sources, and other tools. In certain situations, evacuation may also be the preferred way to prepare for devastating hurricanes. Thunderstorm. Now, it's time to cover your ears and stay indoors once again, because this next one is about to get loud. Did you hear that just now? That was the sound of thunder in a thunderstorm. A thunderstorm is a storm that is characterized by the presence of cumulonimbus clouds that produce lightning, and of course, its accompanying acoustic sound, thunder. Now, when discussing thunderstorm formation, we have to start with the wind and clouds. Warm air rises, carrying moisture and water vapor. These then condense and form into clouds. As the water vapor condenses, it releases energy in the form of latent heat from condensation. This release pushes the cloud higher into the sky. If the conditions are right, this process continues until the clouds form into cumulonimbus clouds. These are the dense, towering clouds usually associated with lightning and storms. Thunderstorms undergo 3 stages. Let's take a look. The first stage is called the developing stage. This is the stage where cumulonimbus clouds form from the condensation of water vapor. As the clouds release latent heat, they move higher and create an updraft of air. This then creates a low-pressure zone and a storm beneath it. The next stage is called the mature stage. This happens when the rising warm air can no longer rise any farther. As the rising air has nowhere else to go, it is forced to spread out. This is the reason why storm clouds usually have a very dense anvil shape. During this stage, water vapor in the clouds coalesce into bigger droplets. These droplets may in turn become precipitation in the form of rain, or if the temperatures are low, may fall as hail instead. This stage is also the time when strong winds and lightning forms, and in some extreme cases even, form tornadoes. And finally, the last stage is called dissipation. At around 20 to 30 minutes into the storm, the downdraft of the air will push the storm to the ground and spread it out. The cool air carrying the storm downward cuts the inflow of the thunderstorm and causes it to dissipate. Thunderstorms are known to be very destructive, and so it is advised to stay indoors during one. Thunderstorm hazards include lightning, hail, tornadoes, flooding, and strong wind bursts. There are also findings that these can trigger allergic reactions, such as asthma. While all thunderstorms will eventually dissipate, some thunderstorms may become severe, and with it, the increased risk to human safety. Thunderstorms, after all, can pretty much happen all year round, and so safety and preparedness is paramount. Tuning in to weather forecasts can help one to be alert and prepared in case of a brewing thunderstorm. If you are outside during one, seek shelter, or better yet, stay indoors. Avoid open areas like hilltops, fields, and beaches. It's also a good idea to avoid tall objects like trees and towers during a thunderstorm. Solar flare. Get your sunblock ready, because it's about to get hot. And no, we're not talking about summer. Because for today, we are talking about the sun, but more specifically, solar flares. So off we go from Earth, and let's take a look at space. Now, we all know the sun, the star that is at the center of the solar system, where of course the Earth lies. It is our primary source of light and warmth. But did you know that beyond these are countless physical and chemical reactions that create the immense energy of the sun? A closer look at the sun reveals large explosive movements that are reminiscent of wildfire. What these are in fact are what is called solar flares. Solar flares are the bright flashes that can be observed on the surface of the sun. These emit a wide variety of energy types. The energy released by a solar flare is typically around 1 × 10⁻20th power joule. Or you can write that as 1 followed by 20 zeros. Now, to put the energy into perspective, you can think of it as the same amount of energy as a volcanic eruption, only 1,000,000 times stronger. But the energy of a solar flare does not stop there. A stronger type of solar flare event, called major solar flare event, can reach energy levels of about 1 × 10⁻25th power joules, which is roughly the equivalent of 1 billion megatons of TNT. Aside from the immense energy, solar flares also eject clouds of particles made up of atoms and ions. Sometimes, these particles even reach Earth after 1 to 2 days. Now, let's talk about how these things occur. When electrons speed up and interact with the plasma on the surface of the sun, this causes the phenomenon of magnetic reconnection. When this happens, a large amount of energy is released along with a big eruption of energy emissions. So, how do solar flares affect the Earth? Well, solar flares influence what is called space weather near the vicinity of Earth. Emissions from solar flares also produce what is called solar wind, which can affect the Earth's magnetosphere. This also carries harmful radiation, which is especially harmful to spacecraft and the astronauts in it. In extreme cases, solar flares can cause a coronal mass ejection, or CME. This release of energy is known to cause massive interference, which can disable radio satellites, causing disruptions to Earth communication systems, which include radio, TV, broadcast, cellular communication, navigation, and even the internet. Imagine, just a single CME can cause such widespread damage. But that's not all. CMEs are so powerful that they can also disrupt power grids, which can cause blackouts to communities. We are nearing the end of this episode. But before we go, let's take a quick recap. In this episode, we learned seasons are divisions of the year which are based on changes in the weather. Some regions of the planet experience 4 seasons, while others only 2. The changing seasons on Earth are caused by the Earth's tilt and rotation. These factors affect the amount of sunlight that different regions receive, which in turn affects the weather. Droughts are prolonged periods of time where a region receives little or no precipitation. Droughts can be caused by many factors, including high amounts of sun exposure, a regularly occurring dry season, the El Niño phenomenon, and high amounts of high-pressure air. Hurricane is the term used in regions in the Northeast Pacific and the Atlantic to refer to tropical cyclones. Storms that are caused by low-pressure areas that are formed by the rising warm air in the oceans. A thunderstorm is a storm that is characterized by the presence of cumulonimbus clouds and lightning, as well as the accompanying sound of thunder. Thunderstorms usually come with strong winds and large amounts of precipitation, and in extreme cases, even tornadoes. And finally, solar flares are the strong explosions at the surface of the sun. These are caused by the interaction between electrons and plasma on the sun's surface. Solar flares cause a type of emission called CME, which can cause interference with the Earth's power grids and communication systems. Rainbow. In previous episodes, we have been talking about the awesome and oftentimes destructive force of weather and nature itself. But surely, it can't be all rainy and stormy all the time. And so for once, let's take a break from that and talk about the weather phenomenon that's sure to be the light after the storm. We are of course talking about the rainbow. The colorful band of light that appears after the rain. If you're feeling lucky, legend has it that there's a pot of gold at the end of one. While we can't promise that, we can at least shed some light on the natural phenomenon that is rainbows. Technically speaking, a rainbow is the effect that is caused by sunlight that is refracted and dispersed by the tiny water droplets in the atmosphere, usually after rain or precipitation. White light, or in this case, sunlight, is the combination of all the colors in the visible spectrum of light. When this light passes through water droplets in the air, it undergoes refraction, or the bending of light, and thus we are able to see the different colors of the rainbow. Now, the colors of the rainbow are actually a continuous spectrum of light. But for simplicity's sake, you might remember learning from school that there are 7 colors in the sequence: red, orange, yellow, green, blue, indigo, and violet. And of course, the old mnemonic device to remember them by is Roy G. Biv. But did you know that aside from water in the atmosphere, rainbows can also form near places where there are bodies of moving water? You might be able to observe rainbows from near waterfalls. These are known as prabows and follow the same process of refraction that produces rainbows. Another place to observe rainbows are near geyser eruptions. As the geyser sprays water from the ground, sunlight and water droplets from the geyser can also form rainbows. Wind and sea water can also create small visible rainbows too. Rainbows can also be observed during fog, as fog itself is formed with water droplets. And of course, we already know what happens when these are exposed to light. Did you know, while rainbows appear to be in the shape of an arc, they are in fact circular? This is because only a section of the circular rainbow is visible within the line of sight of an observer's eye. The circular shape will only be evident once the rainbow is viewed from a high enough altitude. And finally, every rainbow you see is one of a kind. This is because rainbows will appear differently to each person's point of view, and the angle they are viewing it, and the angle that the light from the rainbow will reach their eyes. This means that the way you see and observe a rainbow will always be unique from everybody else. Hail! It's time once again to stay indoors. Because maybe this next one is a big hit. We're kidding, of course, but hailstorms are no joke and can be very destructive. And so, without further ado, let's take a look at what hail is. Hail is a form of solid precipitation that is characterized by solid irregular lumps of ice falling from the sky. They typically measure between 5 millimeters or 0.2 inches to 15 millimeters or 0.6 inches. The larger ones are comparable to a baseball in size. Just like rain and other forms of precipitation, hail is produced from water and clouds in the atmosphere, but with some very specific conditions. So let's take a look. In a previous episode, we talked about thunderstorms and cumulonimbus clouds. These are in fact essential in the formation of hail as precipitation. Sometimes, when thunderstorms produce hail, they are also called hailstorms. An updraft of air carries high amount of liquid water into the cumulonimbus clouds. When the temperature is just right at 0 degrees Celsius or 32 degrees Fahrenheit, these droplets freeze inside the cloud. As the updraft continues to carry them upward, more of the droplets freeze and even combine to form bigger icy lumps. This continues until the ice becomes so heavy that the updraft of air can no longer carry it. And then, gravity takes over and the ice falls down to the earth as hail. There are of course other types of frozen precipitation, such as snow and sleet. But they have a few key differences that differentiate them from hail. Hail is formed from different layers of frozen water droplets in the sky, giving it a solid and sometimes lumpy shape. Snow, on the other hand, takes on a fine crystalline structure, while sleet or ice pellets are formed from a combination of rain and snow and are usually smaller than hail. Hail poses some serious hazards, especially the larger ones, because they are hard solid masses that fall at a great velocity. And speaking of sizes, did you know that the heaviest recorded weight of a hailstone was 1.02 kilograms or 2.25 pounds? This was recorded in Bangladesh in 1986. While the largest diameter of a hailstone was measured at 7.9 inches or 20 centimeters, which was found in South Dakota in 2010. Many properties such as automobiles, aircrafts, lighting, roofing, and even livestock and crops are at risk of damage due to hailstorms. Luckily, hail can be detected through the use of weather radars coupled with decades of data on hail and thunderstorm occurrence. Modern radars are also equipped to detect precipitation rates as well as the relative sizes of hail. Staying indoors will be the best bet to protect against hail, as well as avoiding the use of vehicles and aircraft. Although in extreme cases, evacuation may be required for humans and animals to avoid the hazards and risk from hailstorms. Global warming. You may have heard of it in the news and media for decades now. Something about the weather growing hotter and hotter. The implications are endless for the environment. Melting ice caps, rising sea levels, animal migration, rising temperatures, and extreme weather events. So, let's talk about global warming. Global warming is the term used to refer to the increasing temperature of the Earth's climate because of human activities. Some scientists also use the term climate change because of the complexity of factors that affect weather systems, which not only causes rising temperatures, but also slight cooling short-term effects. So, why is the temperature of the planet rising? Well, it has something to do with what is called the greenhouse effect. As the name suggests, this effect describes heat that is being trapped in the Earth's atmosphere. This is caused by the gas known as CO2 or carbon dioxide. While it is true that trapped heat in the atmosphere makes the Earth's climate livable, the excessive production of CO2 from burning fossil fuels over the decades has been steadily increasing the Earth's temperature. Since the Industrial Revolution, it is estimated that the amount of CO2 in the atmosphere is more than a third of what it once was. And so, what's the big deal? How does global warming affect our planet? In previous episodes, we have noted that most of the weather phenomena on Earth are products of the movement of warm and cool air. And so, global warming and climate change has a direct effect on the Earth's weather system. Allowing more extreme and unexpected weather events to occur, as well as the continued rise of sea levels. This means stronger storms, the possibility of longer dry seasons, and the flooding of habitable land masses. All of these will be challenging for humans and the environment, as habitats, food supply, and safety are all at risk. But what can be done to mediate the effects of global warming? Well, that's where scientific and social interventions come in. There are steps and initiatives being taken at local and international levels to decrease carbon emissions by using environmentally friendly alternatives to fossil fuel, like fuel cells, electric hybrid vehicles, solar power, hydroelectric power, and geothermal power sources. There are also international treaties and agreements, such as the Kyoto Protocol and the Millennium Development Goals, that promote and incentivize decreasing carbon emissions for countries. But we cannot do it alone. Global warming is a collective problem that affects all of us, and so everyone is enjoined to do their part. Even small steps at home can help with lessening the impact of CO2 on Earth. We are, after all, living on the same planet. Forecasting. Nowadays, it would not be very far-fetched to look up the weather on your phone before you head on out and go on with your day. Today, it's sunny, so you wear your light clothes and maybe bring a hat. Tomorrow's forecast is rainy, and so you bring a jacket and an umbrella. And while we might take these little things for granted, the study of meteorology and the way we predict weather has gone leaps and bounds over the past few centuries. And so, let's take a closer look at weather forecasting. But first things first. Here's a quick refresher on weather. Weather is the product of the interaction of the day-to-day changes and movements of air in the atmosphere. The movement of warm and cold air is what produces the kind of weather that we will experience in a particular place and time. And because of this, predicting the weather has become a necessity for human civilization to progress throughout the centuries. The applications span many fields, such as agriculture, the economy, transportation, nutrition, health, migration, engineering, architecture, fashion, and so many other facets of day-to-day life. Even ancient civilizations have their very own data and observations on weather. By the 1600s, scientists like Galileo have started using early instruments like barometers and thermometers to observe the weather. And by the 1800s, rudimentary weather maps were already in use. These types of early forecasts relied on something known as persistence. This is the assumption that past weather events would dictate future behaviors. And while this would work for regularly occurring weather events, it would not be entirely accurate to predict spontaneous and quick occurring events. And so, today's modern weather forecasting relies on very recent data and statistics that are input in a computer simulated model to more accurately predict weather events. This data comes from many advanced sources such as radars, weather balloons, satellite imagery and data, aircraft imagery, and ocean buoys. To create a three-dimensional model that allows meteorologists to simulate the very conditions of the Earth's atmosphere and predict the weather down to the next few days or even hours. But that is not to say that everything now is accurately predicted. You might experience some days where predictions are not as accurate with what you saw on the forecast. That is because even with all the data and computing power, the weather itself is still chaotic and may change at a moment's notice. Factors such as the change in wind speed or direction and dips and peaks in temperature may not be accurately predicted down to the second. But despite this, we cannot overstate the usefulness that we get out of weather forecasting. And so, the next time you go out of your house and you manage to keep yourself dry, you can thank years of countless research and data for your daily weather forecasts as you continue on with your day-to-day life. Typhoon Haiyan. We can't talk about nature's force without looking at some of the most devastating storms in recent history. In this episode, let's take a look at Typhoon Haiyan, which affected the Philippines and parts of Southeast Asia in November of 2013. Typhoon Haiyan is considered as one of the strongest tropical storms in recorded history, with winds having speeds of up to 313 kilometers per hour or 194 miles per hour. It was estimated that Haiyan produced as much as 281.9 millimeters or 11 inches of rainfall in a period of 12 hours, and produced waves of up to 7 meters or 22.9 feet in height off the coast of the Philippines. A tropical storm warning was first issued near Palau and Micronesia on November 3, 2013. On November 4, the storm, now named Haiyan, intensified and was forecasted to travel a path towards the Philippines. On November 6, the storm passed over Palau and caused some damage to trees and power lines in Koror, its most populated city. By November 7, Haiyan entered the Philippine area of responsibility and was given the local name Yolanda. It made landfall the next day at 4:40 a.m. local time. On November 9, Typhoon Haiyan left the Philippines and headed for Vietnam and made landfall there the next day. Now with weekend winds estimated at 120 kilometers per hour or 74.5 miles per hour. And finally, on November 11, Haiyan crossed over into southern China, where it eventually dissipated over Guangxi. In its wake, Typhoon Haiyan left damages that are estimated to be worth at least $5.8 billion. It left as many as 6 million people without a source of income. As a major agricultural country, the Philippines experienced widespread damage to rice, corn, and sugar-producing regions within the country. Tacloban Airport, a province in the Visayas region of the Philippines, was severely damaged and left unoperational. As many as 30,000 fishing boats off the Philippines' coastal communities were damaged. The casualties of Typhoon Haiyan were estimated to be around 7,000, while another 1.9 million were left homeless. Disease outbreaks and malnutrition became common due to the lack of sanitation facilities, food, water, and medicines. The Philippine government has estimated that 71,000 hectares of farmland was destroyed due to excessive rain and flooding. Uprooted trees amounting to thousands has led to a massive release of carbon dioxide and the loss of habitat for tree-dwelling species. While roads became impassable for days because of the debris littering the streets. The devastation after the storm has left the Visayas region of the Philippines fending off what was termed as a humanitarian crisis. Around 6 million people from the region were displaced, and some of them even left homeless. Tacloban, the city which was hit hardest by the storm, had 90% of its structures destroyed. In response to this, monetary aid has been raised and donated by various international bodies, governments, and various non-government organizations and entities. The storm also reignited interest and calls for climate change measures to be undertaken by governments and international bodies. We are nearing the end of this episode. But before we go, let's take a quick recap. In this episode, we learned rainbows are the effect caused by sunlight being refracted by the tiny droplets of water in the atmosphere. While the light we see is a continuous spectrum, they are often simplified into 7 colors: red, orange, yellow, green, blue, indigo, and violet, or simply Roy G. Biv. Hail is a form of solid precipitation. Hail is produced when water droplets from the updraft of air freeze inside the cumulonimbus clouds. These frozen lumps of ice continue to move upward and combine with other ice particles until they become heavy and eventually fall to the ground. Forecasting is the term used for the various methodologies used in predicting the weather. Old forecasting methods used to rely on observation and persistence, while modern methods now rely on data collection and computer simulations. Global warming is the term used by scientists and researchers to describe increasing temperatures of the planet due to human activities, such as the consumption of fossil fuels. This emits a gas called CO2, which causes a greenhouse effect that traps heat in the Earth's atmosphere. Global warming has many effects on the planet, including extreme weather events, rising of ocean waters, flooding, and extended dry seasons. And finally, we took a look at one of the strongest storms recorded in history, Typhoon Haiyan, which mostly affected the Philippines and places in Southeast Asia in November of 2013. It had recorded wind speeds of up to 313 kilometers per hour or 194 miles per hour. In its wake, Haiyan left a trail of destruction that was estimated to be at almost $5.8 billion. And with that, another episode comes to a close. We hope you had a fun and informative time watching. But until then, keep safe. Stay dry and warm when you can. And we'll catch you next time for another rain-inducing, storm-brewing episode of nature's force.